All right. We'll start with the principle of atomic conservation. What this principle essentially is saying is that the number of atoms you begin with is the number of atoms you end up with of any particular element. During a chemical reaction, atoms are not created or destroyed. What changes is the association. Like we saw in the example last week, that earlier the nitrogen was bonded to other nitrogen atoms, right? Because it was existing as nitrogen molecule. And when it reacts with hydrogen to form ammonia, now it is bonded to hydrogen. But the nitrogen atom remains nitrogen. That cannot change, right? उसका अस्तित्व तो नहीं बदल सकता ना. So agar I had 10 nitrogen atoms, I will end with how many nitrogen atoms? 10. That is essentially what the principle of atomic conservation is. That the number of atoms of any element which I begin with must remain the same. That cannot be created or destroyed, right? So if I have a general reaction, let's say A2B3 plus AB4 giving A5B6. I don't know, it's a random reaction which I've written. Okay? And I tell you this, that at the beginning of the reaction, I have, let's say, X moles of this compound and Y moles of this compound and nothing of this, right? At the end of this reaction, this is completely consumed, this is also completely consumed. These two compounds, A2B3 and AB4, are completely used up, and I have in the end only some Z moles of A5B6. Now, what can I say about the number of atoms of the element A? The number of atoms of the element A must be the same before the reaction and after the reaction. So I am essentially applying the principle of atomic conservation for A. The number of atoms of A before the reaction and after the reaction must be the same. How many atoms of A did you have before the reaction? I had X moles of this compound. So how many atoms of A? 2X. One molecule has 2 atoms. So 1 mole will have 2 moles of atoms. So X moles will have 2X moles of atoms. So initially I had 2X moles of atoms of A from this compound. And how many atoms of A from this compound? Y. I had Y moles of atom of A from this compound. At the end of this reaction, ये पूरा खत्म हो चुका है. The only place where the atom A is left is this compound. And how many atoms of A do I have? 5Z. I have 5Z atoms of A. This equation must be true. The number of atoms of A I begin with must be equal to the number of atoms of A I end up with. Yes. And then I can also apply the principle of atomic conservation for the element B. What does this tell you? I had 3X atoms of B in the first molecule. How many atoms of B did I have in the second molecule? 4Y. This is equal to 6Z. I had 6Z atoms of B in the product. Yes or no? Yes, this is POAC. I can solve these equations. If I have 3 variables here, X, Y, and Z, so I could be given another equation, another information which will give me a third equation. For 3 variables, I need 3 equations. For 2 variables, I need 2 equations, and so on. Right? So let's start solving. Class assignment 3, question 1. 2 moles of K4FeCN6 is reacted with a series of reagents such that all the carbon is converted. Connected नहीं होगा, वो converted होगा. Such that all the carbon is converted to oxalic acid. How many moles of oxalic acid will be formed? Oxalic acid is this, COOH, COOH, right? The question is saying that I have 2 moles of potassium ferrocyanide and I am reacting it with a series of reagents. Now I don't know what those reactions are, and that does not even matter. I'm applying principle of atomic conservation. I don't care what the intermediate steps are. Eventually I convert all of it to oxalic acid in such a way that all the carbon which I had here is present in the oxalic acid. Right? So by applying principle of atomic conservation for the element of carbon, what can I say? That the number of atoms of carbon I began with must be equal to the number of atoms of carbon I end with, right? Let's say I end with X moles of this compound. Suppose I have to find out this X, right? Now applying POAC for carbon atom. How many atoms of carbon did I begin with? 12. 12. 1 mole will have 6 moles. So 2 moles will have 12, right? 2 into 6. This must be equal to how much? 2x. Yes, 2x. One molecule has 2 carbon atoms. One molecule of oxalic acid has 2 carbon atoms. So 1 mole would have 2 moles of carbon atoms. So x moles will have 2x moles of carbon atoms. This must be equal to 2x. So x is 6. The answer is 6 moles. Yes. If I ensure that all the carbon present in K4FeCN6 is now present in oxalic acid, then the answer is 6 moles. All right, next. Question 2. Now in question 2, we have iodine and chlorine reacting to form ICl and ICl3. Now first of all, outside of this question, tell me if I have P4 plus O2 giving P4O6 plus P4O10. Can you balance this equation for me? Can you balance this equation for me, please? P4 then and 1, right? Good, you balance this equation. But what about this? Is this correct? But is this correct or not? Is this balancing correct? Alright, 4 3s are 12. 12, 6 2s are 12 plus 10, 22. 22, ये balancing सही है ना? What if I give you this? Is this balancing also correct? Right? ये कैसे हो रहा है? ये तो अजीब बात हो गई ना? Right? I have one chemical equation which I am balancing in 3 different ways. I can balance this in infinite number of ways, right? Which means the stoichiometry is not fixed, which is very absurd, is it not? The stoichiometry in which a reaction happens is fixed. But how is this happening? Why is this happening? Because these are 2 different chemical reactions. Phosphorus and oxygen combining to form P4O6 is one chemical reaction. Phosphorus and oxygen combining to form P4O10 is another chemical reaction. It is wrong to write 2 chemical reactions in one equation. This is incorrect. You should not do this. Are you getting it? If you do that, you will not be able to balance this equation correctly, because I have shown you 3 ways. There are infinite number of ways in which I could balance this chemical equation, right? To balance a chemical equation, only one method is possible. Jaise, if I give you this, if I gave you hydrogen plus oxygen reacting to form water, right? What is the balancing of this equation? 1/2 1, or 2:1:2. Whether I write it as 1:1/2:1, or if I write it as 2:1:2, it's the same ratio. I'm changing the numbers, but it is the same ratio. Here what is happening? These are different ratios. These are different ratios, which is wrong, which cannot happen. Hydrogen and oxygen can combine to form H2O2 also. What will be the stoichiometry in this case? 1:1:1. Is there any other stoichiometry possible here? No. और कुछ हो ही नहीं सकता ना. Can you get a different ratio here? Impossible. Right? It's impossible to get any other ratio. Why? Because this is a unique chemical reaction. But what if I gave you this? Hydrogen plus oxygen giving H2O plus H2O2. This equation you can balance in 100 ways. Infinite number of ways you can balance this equation. It is wrong to write this. Why? Because they are 2 different chemical reactions. I cannot represent 2 different chemical reactions using the same equation. Make sense? So when you're solving problem number 2, iodine and chlorine reacting to form ICl and ICl3, you cannot solve this equation by balancing. Why? Because these are 2 different chemical reactions. हम इसको एक साथ लिख के बैलेंस करके आंसर नहीं ला सकते. because there are many ways to balance it. There are infinite ways to balance this. So you cannot get a correct answer, right? So I2 plus chlorine will give ICl, and I2 plus chlorine will give ICl3. These are two different chemical reactions. These are two different chemical reactions. Make sense? Right? So, how will I solve this? I will apply principle of atomic conservation. Now it is given, how much of iodine did I begin with? 3 moles. How much chlorine did I begin with? 8 moles. Let's say I get X moles of ICl and some Y moles of ICl3. Suppose this is the situation, right? I need to find out X and Y. That is what the question is asking. The question has also given me an extra information that iodine and chlorine are completely consumed. देखो question में लिखा है ना, they react completely. So there is no I2 or Cl2 left at the end of the reaction. All of it has been converted into ICl or ICl3. So let's apply. Let's apply principle of atomic conservation for the element iodine. The number of iodine atoms before and after the reaction must be same. Now, how many atoms of iodine did I begin with? 6 moles of atoms. Yes, I had 3 moles of I2 and each molecule has 2 atoms. So I began with 6 moles of iodine atom. How many did I end with? X moles of iodine atom coming from ICl plus Y moles of iodine atom coming from ICl3. This is equation 1. समझ आ रहा है कि नहीं? And then we'll also apply principle of atomic conservation for the element chlorine. We'll apply POAC for chlorine. What will we get? How many atoms of chlorine did I begin with? 16. 8 into 2, 16. And how many do I end up with? X plus 3y. This is equation 2. Please solve for X and Y. I hope you know how to solve simultaneous equations. Please solve for X and Y and tell me the answer. You will get from here X equal to 1 mole and Y is 5 moles. So we get 1 mole of ICl and 5 moles of ICl3. This is the answer, right? Balancing and solving this would be wrong. And writing it as I2 plus Cl2 giving ICl plus ICl3 is also wrong, because they are two different chemical reactions. Huh? Answer same ही आ रहा है मतलब? नहीं, वो तुम्हारा लक अच्छा था कि तुम उसको उस तरीके से बैलेंस किए कि तुम्हारा आंसर सेम आया, बट हम तो उसको और भी तरीके से बैलेंस कर सकते थे ना. I could have balanced it in some other way also. In that case, your answer would be wrong. Yes or no? You were lucky that you got the correct stoichiometry. Is it okay? All right. Next, question 3, please. Okay. Let's understand what is happening. I have a silver coin. Right? I'm sure all of you have seen a silver coin. I have a silver coin which I treat with certain chemical reagents, and eventually, what am I left with? AgCl. AgCl is a white precipitate. Right? AgCl is a white precipitate. Now, this silver coin weighs 200 grams. The weight of the silver coin is 200 grams. This is given in the problem. But not all of it is silver. There may be some impurities in this, because the question is asking me for the purity of the silver. So not all of it is silver, right? Maybe out of this 200, 150 gram is silver or 140 gram is silver. That is what we need to find out. How much of this coin is actually silver? If I can find that out, then I can calculate the percentage purity. Right? Suppose 150 grams is silver, then I can say 150 by 200 into 100, that's 75%. Right? Is that 75%? Yeah. So 75% is pure. Right? That way we can judge. So what we do, we first dissolve the silver in nitric acid, HNO3. It becomes silver nitrate. Silver nitrate is a soluble salt. I ensure that my nitric acid is in excess. Why do I need that? Why should I have excess of nitric acid? Because if nitric acid is my limiting reagent, then what will happen? All the silver will not dissolve. But I want all the silver atoms present in this coin to be converted into what? AgNO3. Right? All the silver atoms present in this coin have been converted to AgNO3. Next, I add NaCl, also in excess. What does this form? AgCl. Because the NaCl is in excess, all the silver atoms which were in AgNO3 are now precipitated as AgCl. And this This is obtained as 143.5 gram. This AgCl was measured and it was found to be 143.5 grams, right? And now the question is asking for purity of this silver coin. Can I not safely say that the number of silver atoms I began with in the silver coin must be equal to the number of silver atoms in that white precipitate? Principle of atomic conservation. जितना का सारा सिल्वर जो था वो सारा का सारा AgNO3 में कन्वर्ट हुआ है, वो सारा का सारा AgCl में प्रेसिपिटेट हुआ है. All the silver atoms which were there in this coin are also present in that AgCl precipitate. I can say that, right? Okay. So this weight of AgCl3 is 143.5 grams. How many moles of AgCl do I have? 1 mole. Because the molar mass of AgCl is 108 plus 35.5 is 143.5 gram. So I have 1 mole of AgCl. Yes, I have 1 mole of AgCl. Silver is 108. Now you don't need to remember this data. The atomic masses of all elements will be given in your question paper. जो भी required है problem solving के लिए, it will be given in the question paper. So the number of moles of AgCl is 1. If I have 1 mole of AgCl, then how many moles of silver atom do I have? 1. Because every molecule has 1 atom. So if I have 1 mole of AgCl salt, then I have 1 mole of silver atoms. If I end with 1 mole of silver atom, how much must I have began with also? 1 mole. अगर 1 mole finally मिला तो शुरू में भी 1 mole ही होगा. The number of silver atoms should also be in the beginning should also be 1 mole. If I have 1 mole of silver atom, what is the weight of silver in this? 108 grams. But how much was the weight of the coin? 200 grams. How much of it was actually silver? 108, right? So percentage purity is 54%, yes. 108 by 200 into 100. 54% is the answer, right? So you can do this at home. Ask your mom for a few silver coins. ठीक है, tell her मैं बताता हूँ ये 99 है कि नहीं है. ऐसे लिखा रहता है ना silver coins के ऊपर 99.99, right? So you can check that. All you need is silver, nitric acid, some common kitchen salt, and a weighing machine. Right? That's all you need, and you can determine the purity of silver. Yes. Yes. Silver is actually found in nature as AgCl. Right? We have rocks of AgCl. They're called horn silver. That's how it exists in nature, and it is refined from AgCl to pure silver using a process called the MacArthur Forest cyanide process, which we will study in class 12. The MacArthur Forest process. Anyway, so it's easy to do, right? It's not difficult at all. What if you wanted to determine the purity of some gold jewelry at home? तो और ज़्यादा डांट पड़ेगा, right? Gold does not dissolve in nitric acid. What do you need to dissolve gold? Oh yes, good, aqua regia. Nitric acid is unable to dissolve gold. It's a noble metal. So we use aqua regia. That's HCl and HNO3 in the ratio 3:1. Then you can dissolve gold. But then we'll discuss that later. Right? The combustion of carbon takes place in 2 steps. Carbon reacts with oxygen to form carbon monoxide. The carbon monoxide then again reacts with oxygen to form carbon dioxide. Now, why I am giving you this reaction in steps is because, let's say, I began this reaction with, let's take case 1. Is 3 moles, and let's say number of moles of carbon is 4 moles. Right? Say I began the reaction like this. At T equal to 0, I have 4 moles of carbon, and I have 3. What I'm saying is, let's say thoda sa reaction hua, right? Some carbon was consumed, some oxygen was consumed, and as a result, some carbon monoxide was formed. Now notice, in the reaction container, what is present? Carbon, oxygen, and carbon monoxide. Now this carbon monoxide can also react with the oxygen to form what? Carbon dioxide. The point to remember here is that unless all the carbon has been consumed, the carbon monoxide does not start to react with the oxygen. Means until the first step of the reaction is completely finished, the second step cannot start. Is it okay? So make a note regarding this, that the second step of the reaction, the second step of this combustion reaction, the second step of this combustion reaction, note pehle likh lo, you'll get time to write the reaction. The second step of this combustion reaction only begins once all the carbon has been consumed. The second step of this combustion reaction only begins once all the carbon has been consumed. Is it okay? Right? Now what I'll give you is also a trick. We calculate the ratio number of moles of oxygen taken upon number of moles of carbon taken. Right? Like for in this case, how much is this ratio? 3/4. Just by looking at this ratio, you can tell what will be the composition of the final reaction mixture. And all you need to remember is this line. Dhyan deo. If this ratio lies between 0 and half, then your final reaction mixture will contain carbon and carbon monoxide. If this ratio is exactly half, then your final reaction mixture will contain only carbon monoxide. If this ratio is between half and 1, then your final reaction mixture will contain carbon monoxide and carbon dioxide. If it is exactly 1, then it will contain only carbon dioxide. It will contain only carbon dioxide. If it is more than 1, it will contain carbon dioxide plus oxygen. Okay? Just by looking at this ratio, you can comment on the composition of the final reaction mixture. You will not be able to say how many moles of each, but क्या क्या बचेगा finally container के अंदर, ये तुम बस direct बता सकते हो. You don't need to solve the problem. You will be able to directly tell this, and I'll prove this. Let's take this example. Case 1. I have 3 moles of oxygen and 4 moles of carbon to begin with. Right? Now, for the first reaction, I need to balance it. सबसे पहले तो balance करना जरूरी है. How will I balance it? 1, half, 1. I can balance it like this. So the stoichiometry between carbon and oxygen is 1 and half. Can you tell me, between carbon and oxygen, which is the limiting reagent? Which is the limiting reagent? Carbon. Because think about it, 1 mole of carbon requires half a mole of oxygen. So 4 moles will require how much of oxygen? 2 moles. The stoichiometry is 1:half. एक को आधा मोल चाहिए, तो 4 को कितना चाहिए होगा? 2. But how much do I have? 3. I have more than the required amount of oxygen. So the carbon is going to be completely over at the end of this reaction. This is the limiting reagent and the oxygen is in. So at the end of this reaction, let me call it T equal to T1. How much carbon will be left? 0. All the 4 moles are gone. How much oxygen will be consumed? 2 moles. 1 mole consumes half, so 4 will consume 2 moles. So 2 moles will be consumed, 1 mole will be left. 1 mole will be left. How much carbon monoxide will be formed? 4 moles. Carbon and carbon monoxide are 1:1. So if 4 moles are consumed, then 4 moles will be formed. Yes, so I'll get 4 moles of carbon monoxide. So at the end of the first reaction, I am left with 4 moles of carbon monoxide and 1 mole of oxygen. So now the second reaction will start. Carbon has been completely consumed. Second reaction begins with 4 moles of monoxide and 1 mole of oxygen and nothing of the dioxide. Now tell me, which is the limiting reagent? First I have to balance it, of course. 1, half and 1 is the balanced equation. Which is the limiting reagent? Oxygen. For 1 mole of carbon monoxide, half a mole of oxygen is required. The stoichiometry is 1:half. So for 4 moles, 2 moles are required. But how much do I have? Only 1. So the oxygen is now the limiting reagent and the carbon monoxide is in excess. As a result, all the oxygen will be consumed. I have no oxygen left. How much carbon monoxide will be consumed? 2 moles. Yes. Half mole consumes 1 mole. So 1 mole will consume 2 moles. So 2 moles of carbon monoxide is consumed. How much is left? 2 moles. How much carbon dioxide will be formed? 2 moles. एक से एक बनता है, तो अगर दो खत्म हुए तो दो बनेगा, right? 2 moles. So finally, in the reaction container, what am I left with? 2 moles of carbon monoxide and 2 moles of carbon dioxide, which is what that line also told me. 3 by 4, number of moles of oxygen upon number of moles of carbon, 3 by 4 is 0.75. 0.75 is here. And I immediately knew, without solving the problem, that my final reaction mixture will have carbon monoxide and carbon dioxide. Make sense? Solve this problem again. Number of moles of oxygen initially taken is 6 and number of moles of carbon is 15. Tell me the final composition of the reaction mixture and the number of moles of each component. Please solve. Okay, let me balance the first equation. 1, half and 1. At t equal to 0, I have 6 moles of oxygen and 15 moles of carbon. Can you tell me which is the limiting reagent? Oxygen. 15 moles of carbon requires 7.5 moles of oxygen, but how much do I actually have? Only 6. So oxygen is my limiting reagent. So how much oxygen will be left? 0. At the end of the first reaction, all the oxygen is gone. How much carbon will be consumed? 12 moles. Half consumes 1, so it will consume 12. How much will be left? 3 moles. I'll be left with 3 moles of carbon. How much carbon monoxide will be formed? 12 moles. Yeah, 3 moles यहाँ बच रहे. 12 moles of carbon are reacting, so ratio is 1:1. I'll get 12 moles of carbon monoxide. That's it. The reaction will stop here. There is no more oxygen left. How will we go to the second step? The oxygen has been completely consumed. So your final reaction mixture has 3 moles of carbon and 12 moles of carbon monoxide. Now what was the ratio here? The ratio was 6 by 15. Now 6 by 12 is half. So 6 by 15 is less than half. 2 by 5. Right? So 6 by 15 ratio is somewhere here. So you could have immediately guessed, without solving also, that your final reaction mixture is going to contain carbon and carbon monoxide. But if you want to know the exact number of moles of each component, then you have to solve it. Yes? Please attempt question 4. How many moles of oxygen am I beginning with? 4 moles. Divide by 32. I have number of moles of O2. If I had asked you number of moles of oxygen atoms, then it would have been 8. But number of moles of oxygen molecule is 4. And number of moles of carbon is 3. Right? So look, what is the ratio? The ratio is more than 1. So even without solving, what can we say? That the final reaction mixture is going to contain carbon dioxide and oxygen. CO2 plus O2 is going to be the final reaction mixture. And we can quickly solve it now. At t equal to 0, I have 3 moles of carbon, 4 moles of oxygen, nothing of carbon monoxide. What is the limiting reagent? Carbon. 3 moles of carbon requires how much of oxygen? 1.5 moles. 1.5. So all the 3 moles are gone. 0 is left. How much oxygen will be consumed? 1.5. How much will be left? 2.5. How much carbon monoxide will be formed? 3 moles. Perfect. Right? This goes for the next reaction. It begins with 3 moles of carbon monoxide, 2.5 moles of oxygen, and nothing of the dioxide. Now again, this time who is the limiting reagent? Carbon monoxide again, because 3 moles of carbon monoxide requires 1.5. 1.5 moles of oxygen, but how much do I have? 2.5. This is again in excess. So carbon monoxide is Lr. Here carbon was Lr, limiting reagent. So this carbon monoxide is completely consumed, 0 moles left. Oxygen consumed is 1.5. So 1 mole is left. How much carbon dioxide is formed? 3 moles. Perfect. So your final reaction mixture is 3 moles of carbon dioxide and 1 mole of oxygen gas. Yes? Cool. Next. Question 6. Problems which are of the type of question 6, right? They will become easier once you have studied more chemistry. Because this involves heating of some compounds. Now you must know what happens when you heat these compounds, right? We have a mixture of sodium carbonate, Na2CO3, and sodium bicarbonate, NaHCO3. Na2CO3 and NaHCO3. And we are heating this. we are heating this mixture. It is given that the total weight is 190 grams. Na2CO3 and NaHCO3 totally gives 190 grams. On heating this mixture, I get 11.2 liters of carbon dioxide. ये दिया हुआ है. The question is asking what is the percentage of sodium bicarbonate in this mixture, percentage by mass, right? So what happens when you heat sodium carbonate? बताओ. Nothing happens. ठीक है, ये भी एक कुछ होना ही है ना, right? Sodium carbonate does not decompose on heating. When you heat Na2CO3, nothing happens. This also will come with time, right? This is part of a section which I teach on heating effects of salts, right? So when I teach you that, then this will become clearer. But don't worry if you don't know this already, it's fine. So if you heat Na2CO3, कुछ नहीं होता. But if you heat NaHCO3, what happens? I Na2CO3 plus H2O plus CO2. Now solve. Now solve. I've given you the chemical reactions involved. Now tell me the answer. Take a minute and solve. The volume of carbon dioxide obtained is 11.2 liters, which means the number of moles of carbon dioxide obtained is how much? Half mole. 22.4 liters of any gas at STP occupies 1 mole. Sorry, 1 mole of any gas at STP occupies 22.4 liters. So 11.2 liters will have half mole, right? But I need to balance this equation also, right? I cannot simply solve it like this. The balancing will be this 2, right? So 1 mole of carbon dioxide is produced from 2 moles of sodium bicarbonate. So half mole of carbon dioxide will be produced from how many moles of sodium bicarbonate? 1 mole. So I know the number of moles of NaHCO3. So can I not find out the weight of sodium bicarbonate? This will come to how much? 84 gram. This will be 84 grams. You can simply add sodium is 23, hydrogen is 1. 23 plus 1 plus 12 plus 48. This becomes 84 grams. So out of the 190 grams, 84 gram is what? Sodium bicarbonate. That's all. That's all. So percentage by mass will be 84 upon 190 into 100. This comes to 44.2%. Okay. This is the answer. Now we come to a very important section of this chapter which deals with solutions. Okay. We've been solving problems with sodium carbonate, sodium bicarbonate, NaOH, HCl, etc. But generally, these things are not available in pure form to us. In a lab, if someone is giving you some NaOH, is he giving you pure NaOH? No. They will give you NaOH dissolved in a solution, NaOH in water. If you are given HCl, will you be given dry HCl, yellow HCl? काम करो इससे नहीं. You will be given a solution of HCl. So we need to understand solutions because that is how we deal with many chemicals practically, right? Now a solution has two components, solute and solvent, right? So solute plus solvent together makes solution, right? A solute plus a solvent together makes solution. Now, if I ask you this question, I have ethyl alcohol, C2H5OH, plus water forming a solution. Right? Ethyl alcohol and water I have mixed and they've made a solution. Which is solute and which is solvent? Water is solvent and ethyl alcohol is solute. But what if I told you that I have a whole glass of ethyl alcohol in which I add 2 drops of water? I have a whole glass of ethyl alcohol, which is the good alcohol. I hope you know this. Right? It is the good alcohol. If it is methanol, then that's bad. Why is methanol bad? Yes, it causes blindness. You might have heard news reports TV पे कभी देसी शराब पी के 4 लोगों अंधे हो गए, right? So what really happens is during the fermentation process, right? When the yeast is fermenting the carbohydrates, some ethyl alcohol is formed, carbon dioxide is byproduct, but sometimes methanol is also formed, and that methanol is poisonous. So CH3OH is poisonous. CH3CH2OH makes you high. Right? If you add another CH2 group, it's again poisonous. Right? So one CH2 is the difference between life and death. 30 ml of methanol, you'll go blind. 60 ml of methanol and you're dead. Right? So it's very dangerous. Methanol is quite dangerous. Ethanol is good. Right? Anyway, so you could be a person who prefers his drink strong. Right? You can have a lot of ethanol with a little dilution, little bit of water. So which is solute, which is solvent? Which is solute, which is solvent? Ethanol obviously is the solvent and water is the solute. Right? Right? So what does it depend on? It depends on amount. Ethanol is a liquid, water is also a liquid, the solution finally is also liquid. It is a liquid-liquid solution, right? In such cases, the component which is greater in amount is the solvent and the component which is lesser in amount is the solute, right? We cannot specifically say कि नहीं यही solvent होगा, right? Right? So make a note, in a liquid-liquid solution, the component greater in amount is the solvent. In a liquid-liquid solution, the component greater in amount is the solvent. Yes? In a liquid-liquid solution, the component greater in amount is the solvent. Straightforward? What if I gave you this? Sugar plus water making solution. Now tell me which is solute, which is solvent? Water is solvent, sugar is solute, it is making a solution. But what if I told you that I have, let's say, 100 gram of water and in that I am mixing 150 gram of sugar to make solution? Now which is, हाँ? फिर भी water ही रहेगा solvent, ऐसा क्यों? उससे क्या फर्क पड़ता है? उससे क्या फर्क पड़ता है? The solution finally is liquid. Water here is liquid and the solute here is solid. Please note, the solvent and the solution must be in the same phase. The solvent and the solution must be in the same phase. PHASE means if the solution is liquid, then the solvent has to be the liquid component. Right? Then the solid component cannot become the solvent. Are you getting it? Right? If the solution is liquid, the liquid component will be the solvent irrespective of the amount. Even though I have lesser water, still it will be the solvent. When will you check amount? When the solute and the solvent are both in the same phase, then the one which is greater in amount becomes solvent. But if they are in different phases, you have to check the phase of the solution. ऐसा भी हो सकता है, solid plus liquid becoming solid. Right? Now which will be the solvent? Solid. Now solid will be the solvent. Irrespective of amount, solid will be the solvent. Can you give me an example? Solid plus liquid becoming solid? Can you give me an example? Essentially, what am I asking you? I'm asking you, can you give me an example of a liquid dissolved in a solid? That is what I'm asking you. Gel. Right? Think about it. Brill cream or any sort of hair gel or jelly. Right? What is the final state? Finally, it is solid. It is not flowing anywhere. It is solid, but it has a liquid dissolved in it. Right? So gels are examples of substances where a liquid has been dissolved in a solid. Yes or no? And the final state is what? Solid. Yes? Can you give me this example? Can you give me an example of a gas dissolved in a liquid? Give me an example of a gas dissolved in a liquid. HCl reacts with water. It dissolves in water, you're right, but it does not remain as HCl, it breaks into H plus and Cl minus. So I will not say that. Huh? Water gas is carbon monoxide plus hydrogen. It's a mixture of two gases. Right? Water gas is not the answer. Give me an example of a gas dissolved in a liquid, a solution where a gas has been dissolved in a liquid. Oxygen dissolved in water? मछलियां सांस कैसे लेती है यार? Right? There is oxygen dissolved in water. What is the final state? Liquid. Cold drink पीते हो तुम लोग? Thumbs up, Pepsi. Carbon dioxide is dissolved in water. Yes. So gas has been dissolved in liquid. This is examples, right? Tell me this then. Can you give me an example of a gas dissolved in solid? If a gas is dissolved in solid, what will be the final state of the solution also? Solid. The final state of the solution also has to be solid. Can you give me an example? It's not a true solution, it's a colloidal solution, which we will study in another chapter. But physically, socho, can you think of a gas dissolved in a solid? And the final state is solid. Yes, yes. How many of you know what a pumice stone is? Pumice stone, P-U-M-I-C-E-S-T-O-N-E. तुमको तो पता होगा. ग्रे कलर का पत्थर जिसे पेडिक्योर मैनिक्योर होता है. हाँ, right? You might have it at home. You can go ask your mom. Right? It's a gray colored stone. It's very light. It's very light. Why is it so light? Because it has a gas dissolved in it. So it's very lightweight. But what is the final state? What is the final phase? Solid. So it's an example where a gas has been dissolved in a solid. Right? Go get yourself a pedicure or a manicure sometime. Right? उसमें वो pumice stone use होता है. Right? Thermocol. Thermocol. Right? Thermocol is solid. But why is it so light? Because it has a gas dissolved in it. That's why it's so light. All right, tell me this then. Give me an example of a liquid dissolved in a gas. Liquid dissolved in gas. Water vapor in the air around us right now. We are right now living in a liquid dissolved in gas solution. Yes or no? Is there not water vapor around us? It is dissolved in the air around us. It is in liquid form. Yes. Clouds, fog, mist. What is all this? Liquids dissolved in water. Yes or no? Water vapor पूरा सही नहीं होगा बोलना, because water vapor बोलना मतलब water already क्या बन चुका है? Gas बन चुका है. तो वो gas dissolved in gas हो चुका अब. If I talk about water vapor in the air, then it is gas dissolved in gas. But if I talk about moisture in the air, then it is liquid dissolved in air. That is liquid dissolved in gas. Make sense? Give me this example then. Solid dissolved in gas. Dust particles, yes. Dust particles are solid. They are dissolved in the air around us. Yes. Smoke. Solid dissolved in gas. Make sense? Make sense? Give me this example. Solid dissolved in solid. Solid dissolved in solid. Alloys, yes. Alloys are solutions of two metals or three metals. Right? So they are all solids. So alloys are mixtures that way. Yes, are you getting it? Right? So we have various types of solutions which are possible. But in this chapter, we'll be focusing on two types. We'll be looking at a liquid solution, and we will be looking at the very common solid in liquid solutions. These two we will be focusing on in this chapter. Now, whenever I talk about a solution, I need to be able to express its concentration. I need to be able to express its strength. जैसे एक बॉटल पानी लिया, उसमें मैं एक चम्मच चीनी डाल दिया. If I take another bottle of water, same volume, but I add 2 spoons of sugar in it. Both of them are sugar solutions, but the second bottle is more concentrated. It has a greater strength, right? So I need some terms which can help me explain, which can help me describe this strength, right? So what we'll now start with are concentration terms, which are very important in this chapter. These concentration terms help us express the strength of a solution. Right? You've understood what solutions are. These concentration terms help us describe this solution. The first concentration term we'll understand is mole fraction. Mole fraction is represented by the symbol capital X. Okay. Mole fraction is represented by the symbol capital X. Now, say I have a mixture of two compounds A and B. Then the mole fraction of A is defined as number of moles of A divided by total number of moles. So Na plus Nb. That's it. This is mole fraction of A. If I have a mixture of A and B, if I have a solution of A and B, then the mole fraction of A is defined as the number of moles of A divided by number of moles of A plus number of moles of B, the total number of moles essentially. Mole fraction of B will be what? Number of moles of B upon total number of moles, Na plus Nb. I could have a mixture of more than two components. I could have a third component here, C. In that case, what would happen? Mole fraction of A would be number of moles of A upon Na plus Nb plus Nc. Right? I would just have another term. I could also define mole fraction of C as number of moles of C upon Na plus Nb plus Nc, and so on. I can have any number of components. I can have a mixture of 3 compounds, 4 compounds, whatever. Make sense? Mole fraction. The sum of mole fractions, Xa plus Xb, will be how much? 1. 1. The sum of mole fractions, the sum of the mole fractions of all the components in a solution will always be equal to 1. The sum of mole fractions of all the components in a solution will always be equal to 1. Make sense? Let's see if you've understood this. Please solve question 8. If I say that the mole fraction of a compound is 0.75, it means that if I had 100 moles of mixture, 75 moles would be that compound. Does it mean that if I had 100 grams of mixture, 75 gram would be that compound? It is a mole fraction, it is not a weight fraction. I hope that's clear. I have 100 gram of mixture. Right? This mixture contains both ethyl alcohol and water. Let's say it has X gram of ethyl alcohol, C2H5OH. So how much water will it have? It will have 100 minus X grams of water. If I know the weight of the components, can I not calculate the number of moles of the components? How do you move from weight to number of moles? Divide by molar mass. Yes. From weight you go to number of moles by dividing with molar mass. Yes. How much is the molar mass of ethanol? You must have calculated this. 46 grams. The molar mass of ethanol is 46 grams. 1 mole of ethanol weighs 46 grams. So number of moles of ethanol is how much? X by 46. What will be the number of moles of water? 100 minus X upon 18. I know the number of moles now. I know the number of moles. Now write down the definition. Mole fraction of C2H5OH. By definition, what is it going to be? The number of moles of C2H5OH upon the number of moles of ethyl alcohol plus the number of moles of water. Hai ki nahi? Will this not be it? The mole fraction of ethanol will be the number of moles of ethanol divided by the total number of moles. Yes? We know the number of moles. Number of moles of ethanol is how much? X by 46. So this becomes X upon 46 upon total number of moles, which is X upon 46 plus 100 minus X upon 18. How much will this be equal to? Read the question. How much will this be equal to? (0.25). The mole fraction of water is given to you. The sum of mole fractions is always 1. If the mole fraction of water is 0.75, then the mole fraction of ethanol will be 0.25, and I've written that. Solve. Solve for X. Simple equation. X will come to 46 grams. Okay, X will be 46. देखो ऊपर क्या आएगा 1, नीचे क्या होगा 100 minus 46 54, 54 by 18 is 3, तो 1 plus 3, so 1 by 4, 0.25. X will be 46 grams. This mixture is 46 gram of ethanol and 54 gram of water. So in 46 grams of ethanol, how many moles of ethanol will I have? 1 mole. And how many moles of water will I have? 3 moles. So what will be the mole fraction of ethanol? 1 upon 1 plus 3, that is 0.25. And what will be the mole fraction of water? 3 upon 1 plus 3, which is 0.75. 3 by 4, 0.75. Is it fine? Next. The average molar mass, this formula we had discussed in the previous class as NaMa plus NbMb upon Na plus Nb. Right? This was essentially what? It was a weighted average. It was a weighted average of the molar masses where the number of moles were the weights associated. Right? Now I can write this in this fashion. Can I not break up this into fractions? It will be number of moles of A upon total number of moles into Ma plus number of moles into B into molar mass of B upon total number of moles. N plus Nb. Can I not break it up into fractions like this? What is this term? Number of moles of A upon total number of moles. This is mole fraction of A, right? And this is mole fraction of B. Number of moles of B upon total number of moles is mole fraction of B. So the average molar mass or the molar mass of a mixture can be even shortened as mole fraction of A into molar mass of A plus mole fraction of B into molar mass of B. Important. Mole fraction of A into molar mass of A plus mole fraction of B into molar mass of B. Right? Please solve the next question very quickly. Number 9, 28.8. Right? The molar mass of air, which is a mixture of nitrogen and oxygen, will be 0.8, which is the mole fraction of nitrogen, into the molar mass of nitrogen, which is 28, plus what will be the mole fraction of oxygen? 0.2, because the sum of mole fractions is always 1, into 32 gram. 28.8 gram. Straightforward. Okay. Now we'll come to another concentration term. Let's understand that. Another term which can help us understand the concentration of solutions is this. It is called percentage weight by weight. Okay, percentage weight by weight. That it is defined as weight of solute upon the weight of solution in 200. This is percentage weight by weight. Weight of solute upon weight of solution in 200. That the solute and the solution must be measured in the same units. Either both are grams or both are kg or whatever, but they must be in the same unit. This is percent weight by weight. It's written like this. Another measurement of concentration is percentage weight by volume. Percent weight by volume. Here in the numerator we use weight of solute, generally in grams, and in the denominator we use volume of solution. This will be in milliliters in 200. Volume of solution in milliliters in 200. This is another way of measuring the strength of a solution. Most medicines, right, these cough syrups and all which you will find at home, go read the pack sometime. Right? When you have a medicine or any product you buy, read the composition. You will notice that these units are generally used. For syrups, etc., in medicines, percent weight by volume is a very common unit. Right? Very commonly used. Another measurement of strength is percent volume by volume. Percent volume by volume. Right? Now, this unit is obviously preferred when both the solute and the solvent are liquid. Right? Because it is volume versus volume. What will be the definition? It will be volume of solute upon volume of solvent, solution, sorry. Volume of solution in 200. Volume of solute upon volume of solution in 200. Again, the solute and the solution must be measured in the same unit, either both milliliters or both liters, etc. Right? This percent volume by volume. What does this mean? Suppose I tell you that a sulfuric acid solution is 10% weight by weight. Right? I've given you the strength of this solution. It means that if I had 100 grams of this solution, out of that 10 grams would be what? Sulfuric acid. That is what it physically means to be 10% weight by weight. कि अगर 100 ग्राम solution होता तो उसमें से 10 ग्राम solute होगा. That is what it means. Make sense? All right. Please attempt. Please attempt problem 10. कितना बताओ? 0.04 is correct. Yes. 1 by 24 did you get? 1 by 24 आया ना? All right. So in number 10, what does it mean? 10% weight by weight of ethyl alcohol in water. It means that if I had 100 grams of solution, then how much of it would be ethyl alcohol? 10 grams, right? So my solution is ethyl alcohol, C2H5OH plus water, and together this is making a solution. If it is 10% weight by weight, it tells us that if I had 100 gram of solution, then 10 gram of this would be ethyl alcohol. So how much would be water? 90 gram. This is what it means. Percent weight by weight 10% means in a 100 gram solution, I would have 10 gram of ethyl alcohol. Now, if I know the weight of my components, can I not find out number of moles? What will be number of moles of ethyl alcohol? 10 by 46. And what will be number of moles of water? 90 by 18, which is 5. Right? If I know the number of moles of both my components, I can calculate mole fraction of ethyl alcohol. That is what the question is asking. Mole fraction of C2H5OH will be the number of moles of ethyl alcohol, which is 10 by 46, divided by total number of moles, which is 10 by 46 plus 5. This will come to 1 upon 24. That's all. Are you getting it? Any doubts? You understand the physical significance of this statement, that 10% weight by weight, it means if I had 100 gram of solution, then 10 gram of it would be ethyl alcohol. Please note, was it necessary to start with 100 gram of solution? No. I could have begun with 200 gram of solution. 10% of that is going to be ethanol, which means how much? 20 gram. So I would have 20 gram of ethanol and 180 grams of water. And if I then did the calculation, I would get the same answer. Because the strength of the solution does not depend on the amount, right? The strength of a solution is like the temperature of a solution, right? If I have, let's say, a solution whose strength is 10%, if I pour out a portion of that solution in another glass, right, what will be the strength of the solution in the glass? Also 10%. It won't change, right? It's like, suppose एक चीनी का पानी है, तुम उसको 2 ग्लास में ट्रांसफर किए, both the glasses will taste equally sweet. Both the solutions will taste equally sweet because they have the same strength. Are you getting it? It's an intensive property. Okay. Can I erase this? The next measurement, the next concentration term, the next two concentration terms are very, very important. Number 5 is molarity. M-O-L-A-R-I-T-Y. It is represented by capital M. Molarity is defined as number of moles of solute upon volume of solution. This should be in liters, right? Number of moles of solute upon volume of solution in liters. This is the definition of molarity. So we often write molarity in short as N by V. Number of moles by volume of solution, molarity is N by V. So from here, we have an expression for number of moles. What can I write number of moles as? Molarity into volume. So number of moles is molarity into volume. This number of moles. Yes, we'll be using this formula very often. And another unit which we have is called molality. M-O-L-A-L-I-T-Y, molality. This is represented by small m. Molality is represented by small m. The definition is number of moles of solute. And now for the first time in our denominator, we will have another term. We will have the weight of solvent. Please note, in all these expressions, what did we have in the denominator? Solution. For the first time, we have solvent. The denominator will be the weight of solvent. Unit will be kg. Number of moles of solute upon the weight of solvent in kg. This is known as molality, small m. Okay? Any doubts? Very important measurements, molarity and molality. A common question which is asked in school exams, that which is a preferred method for measurement of concentration? Which is more accurate? Which is more accurate, molarity or molality? Why? Yes, yes. If I heat a solution, its volume might change. So I have not changed solute, I have not changed solvent, but the volume changes on heating. So the molarity could change with temperature, but the molality, small m, will remain same with temperature, right? So molality is independent of temperature. That is why it is a more accurate unit. But more commonly, what is used? Molarity. In the school lab, you will find molarity is more prevalent. मोलर कम होता है, मोलर ज्यादा यूज होता है. दिस इज रिटन एज MOLAR. If I write 2 capital M, it means 2 molar, and if I write 2 small m, it means 2 molal, MOLAL. Molarity is called molal, molar, MOLAR, and molality is called molal, MOLAL. Molar and molal. Okay, please solve question 11. Please solve question 11 and then attempt 12 and then 13 as well. Please attempt 11, 12 and 13. Right. Have you solved the 3 problems? Okay. Question 11. What is the 20? 9. 0.2 molar. Yes, 0.2 molar is the answer for number 11. 11 is pretty straightforward. The weight of sulfuric acid given is 9.8 grams. So the number of moles of solute, sulfuric acid is our solute, is 9.8 upon 98. 0.1 moles, straightforward, right? So what will be the molarity? The molarity, the strength of the solution is going to be the number of moles upon the volume of the solution. So it will be 0.1 upon, what is the volume of the solution? 500 milliliters, but this has to be in liters. So 0.5 liters. So this becomes 0.2 molar, right? The answer is 0.2 capital M. We call it MOLAR, 0.2 molar. Yes, straightforward. Next, number 12. What is the answer? 800 ml is correct. Did everyone get 800 ml? 800. All right. Let's discuss. We need to understand the basis of solving this. I have a solution which has 200 milliliters volume and whose strength is 1 molar, right? Which means is 200 ml में कुछ sulfuric acid के molecules हैं यहाँ पे, right? There are some sulfuric acid molecules. Now I am diluting this solution. How am I diluting it? By adding more solvent. Have I added any solute from outside? No. I am diluting this solution so that its volume increases to some value. This I don't know. But on diluting this solution, what has the strength decreased to? 0.2 molar. Because the number of molecules of sulfuric acid are still the same. I had this many molecules in 200 ml. Now I have the same molecules in some larger volume. So what will happen to the concentration? The concentration or the strength will decrease. Now the question is asking what is the new volume such that the strength is 0.2 molar. The question is actually asking how much water is added so that the strength becomes 0.2 molar. In this process of dilution, what has not changed? The number of moles of solute. वो change नहीं हुआ ना, because what have I added from outside? Solvent. What is the formula for number of moles of solute? Molarity into volume. That is the number of moles of solute. So molarity into volume for this solution must be equal to molarity into volume for this solution. Yes, let me call this V1 and M1 and let me call this V2 and M2. So how many moles do I have over here? I have M1 into V1. I have M1 into V1 moles here. How many moles do I have over here? M2 into V2. Because I have not added any sulfuric acid from outside, I can simply say M1 V1 must be equal to M2 V2, right? So for dilution cases, the formula which you will use is M1 V1 is equal to M2 V2. Right? You will use M1 V1 equal to M2 V2. So initial molarity is 1 molar into initial volume is 200 ml. This is equal to final molarity, which is 0.2 molar, into final volume we don't know. V2 from here comes to 1000 milliliters. So the volume of this solution is 1000 milliliters. Means how much water was added? 800 milliliters. The question is not asking you for the volume of the final solution. It is asking you how much water is added. So 200 pehle tha, 1000 finally hai, so 800 ml was added. Is it clear? Any doubts? All right. Next, number 13. Have you solved 13? How much? 1.6 is correct. तुम्हारा भी हो गया? Okay, let's understand. I always feel that drawing the diagram will help you. Okay. What is happening in question 13 is we are mixing two solutions. I have this solution, molarity M1 and certain volume V1. Right? How much is the molarity of the first solution? Quickly tell me. 1 molar. How much is the volume? 200 ml. Then I have another solution. How much is the molarity here? 2 molar. How much is the volume? 300 ml. Right? I am mixing these two solutions and I am forming a new bigger solution. Right? And the question is asking how much is the molarity over here. Now this resultant molarity, can I not say this will be the total number of moles of solute upon the total volume? Can I not say this? Total number of moles of solute upon total volume, this will be the resultant molarity, right? Now what is the total number of moles of solute over here? The number of moles of solute coming from here plus the number of moles of solute coming from this solution. How many moles of solute is coming from this solution? M1 into V1? How much ever it is, it will be M1 into V1. How many moles of solute is coming from here? M2 into V2. So total moles of solute is M1 V1 plus M2 V2. And what is the final volume of this solution? V1 plus V2. Sum of both the volumes. So I have a very important formula. The resultant molarity is M1 V1 plus M2 V2 upon V1 plus V2. Now, what I want you to do, you will use this for mixing cases. When you're mixing two solutions, you will use this formula M1 V1 plus M2 V2 upon V1 plus V2. For dilution cases, you will use M1 V1 equal to M2 V2. Now, what is so interesting here is that it is a weighted average. Did we not understand the concept of weighted average? Right? I am taking an average of M1 and M2, but with the weights V1 and V2. Right? It is a weighted average of M1 and M2. So the answer must lie between M1 and M2. Because it is a weighted average of M1 and M2, the answer had to be between 1 and 2. Hey, it is, think of it again in terms of temperature. Suppose you had some water at 30 degrees and some other water at 50 degrees. नहाते समय करते हो ना, गर्म पानी में ठंडा मिलाते हो ना, right? What will be the resultant temperature? It has to be between 30 and 50. It cannot be outside this range. So the resultant over here has to be between 1 and 2. Now, if I had mixed these two solutions in equal volumes, suppose I had equal volume of both these solutions, then what would be the resultant molarity? Exactly between 1.5. अगर 30 डिग्री और 50 डिग्री का पानी है, अगर इक्वल अमाउंट में मिक्स करेंगे तो रिजल्टेंट टेम्परेचर कितना होगा? 40, राइट? बट इफ अगर गर्म पानी ज्यादा डाल दिए तो इट विल बी more than 40. It will be more than 40. Same thing has happened here. I have two solutions whose strength is 1 molar and 2 molar, and I have mixed more of the 2 molar solution and lesser of the 1 molar solution. So can I not immediately say that the resultant will have to be more than 1.5? If I had mixed them in equal amount, then it would have been exactly 1.5. But because ये वाला solution ज़्यादा डाल रहे हैं, so the strength of the resultant solution will be more than 1.5, but less than 2. So even without doing any calculation, just by looking at the problem, you can immediately say the answer is going to be between 1.5 and 2, because it is a weighted average. Yes, maybe only one option was between 1.5 and 2, and you could have directly marked this question and moved on and not spent a lot of time solving it. Yes, makes sense, right? When you solve this, you will get the answer as 1.6, which is matching our observation. The answer has to be between 1.5 and 2. Yes. Everyone's okay with this? Dilution case? All right. Mixing case? Okay. Next. Please attempt. Problem 14. Make a small correction in problem 14. Calculate the volume of 2 capital M. वो small m नहीं होगा. Calculate the volume of 2 capital M, 2 molar NaOH required to completely neutralize 300 ml of 1.5 molar H2SO4 solution. Please solve. देखो, Understand. The question says that I have a container which contains 300 ml of sulfuric acid whose strength is 1.5 molar. I have another container which has a lot of NaOH whose strength is how much? 2 molar. Now the question is asking how much NaOH should I add in this sulfuric acid container so that the sulfuric acid is completely neutralized. That is what the question is asking. So what reaction will happen when I add NaOH into the sulfuric acid container? What reaction is going to happen? NaOH plus sulfuric acid is going to react to form Na2SO4 plus water. Yes or no? This reaction is going to happen. NaOH plus sulfuric acid will give Na2SO4 plus water. I must balance this equation. I'll have 2 over here and I'll have to put 2 over here. Now this equation is balanced. Make sense? Why? I cannot just solve directly. If I'm applying mole concept, I must balance the equation first. Now at t equal to 0, how many moles of sulfuric acid do I have? Now instead of directly giving you number of moles of sulfuric acid, what have they given you? They've given you a solution of sulfuric acid and its strength. So we know how to calculate number of moles. What is the formula? Number of moles is molarity into volume. How much is the molarity? 1.5, right? So number of moles of sulfuric acid is 1.5 into volume is how much? 300 milliliters. I can write this as 45 millimoles. Please note, if I keep the volume in liters, then I will get N in moles. But if I keep the volume in milliliters, I have multiplied by 1000 essentially. So what will I get it? I'll get it as millimoles. I hope you can understand this, that 1 mole is the same as 1000 millimoles. 1 mole 1000 millimoles. जैसे 1 gram is 1000 milligrams. वैसे 1 mole is 1000 millimoles. Rather than writing decimals, this is easier. Right? So I have how many moles of sulfuric acid? I have 45 millimoles of sulfuric acid, or 0.045 moles, or I can also say 45. Wait, 300 into 1.450. 300 into 1.5 is 450. I have 450 millimoles of sulfuric acid. Make sense? How many moles of NaOH will be required? 900, because stoichiometry is 1:2. 1 mole of sulfuric acid will neutralize 2 moles of NaOH. So 450 millimoles will require 900 millimoles of NaOH. But where is this NaOH coming from? It is coming from this solution which has strength 2 molar. So the number of moles of this solution is known. Molarity is known. What is required? Volume. So all I will now write is 900 millimoles is equal to molarity, which is 2 molar into volume. So 450 milliliters. So volume required is 450 milliliters. This is the answer. Is it okay? Any doubts? You will have to do this experiment in school. I hope you realize this. In school, you will have to do this experiment. क्या करना होगा? Suppose this very question is given in school, right? What will you first do? You will take some sulfuric acid in a conical flask, right? Over here, what have you added? This sulfuric acid, you know, its strength is known. How much? 1.5 molar. Suppose this NaOH का strength was missing. इस क्यूबल से लेबल खो गया, right? NaOH container से लेबल उतर गया, and you have this flask, and you have been given a sulfuric acid solution whose strength you know, and an NaOH solution whose strength you don't know, right? And now the question is asking, please find out the strength of NaOH solution. You will have to perform this titration in school. It is part of your board practicals. What will happen is, we'll take some sulfuric acid here, let's say H2SO4, right, in this conical flask. We know the strength of sulfuric acid, 1.5 molar. If I add 300 ml over here, then I know how many moles of sulfuric acid I am adding, because it is simply molarity into volume. How do you add sulfuric acid? How do you ensure? Let's say you add 30 ml, if not 300. Suppose तुम 30 ml sulfuric acid एक flask में डालना है. How do you ensure that you are adding exactly 30 ml? What apparatus do you use in the chemistry lab? No, burette is the long cylinder which you place on top. This is the burette with a tap over here, which can control the flow of the solution. How do you add it in the conical flask? We use an instrument called a pipette. A pipette looks like this. You will have to do this in school. A pipette looks like this, and the pipette has fixed volumes के pipette आते हैं. 10 ml का pipette है या 15 ml या 20 ml या 25 ml. You get fixed volumes pipettes. Let's say there's a 30 ml pipette. So what will happen is there will be a mark over here, right? And on top of this, it will be written 30 ml. So if you fill this pipette up to this mark, then you have exactly 30 ml of solution inside this pipette. So what you do, you take this pipette and you dip it in a solution of sulfuric acid, let's say. And then you have to suck on it like a straw, I say. You really have to do this, right? As you suck on it as a straw, the solution will start to rise. यहाँ ऊपर तक पहुंचेगा. You have to be careful as to not swallow the acid, right? Many students are going to do this. तुम्हारे आसपास कई बेवकूफ होंगे जो acid या base निगल लेंगे, पी लेंगे pipette से. ऐसा होता है. That happens when the level of the solution drops below the pipette. So air के साथ साथ वो base या acid भी मुंह में आ जाता है. So you have to be careful over here. You take 30 ml, you take a little more than the mark, and then you remove the pressure. You move your mouth and you hold your thumb on top. As soon as you hold your thumb on top, you're preventing the inflow of air, so the level does not fall. And then you have to very slowly release your thumb in such a way that the level falls to exactly this mark, right? Once the level has reached this mark, using this thumb covered, you bring it on top of your flask and you release your thumb, right? So this way you have ensured that you've added exactly 30 ml of sulfuric acid over here. So you know the strength of sulfuric acid, you know the volume of sulfuric acid added, so you know how many moles of sulfuric acid you've put over here. This unknown NaOH I put in my burette. The unknown NaOH I put in my burette, right? Now I start to pour this NaOH inside this sulfuric acid. This reaction will start to happen, right? The NaOH will start to consume the 450 millimoles of sulfuric acid which I have here, 30 ml or how much, जितना भी है वो पता है अपने को. It will start to consume that. It'll start to consume that. Now, as that continues to happen, right, there will come a time when all the sulfuric acid in this flask is consumed. But how do I know when that time has been reached? Huh? I need an indicator. I need an indicator. What I do is, there are many indicators which I could use, but let's say I add phenolphthalein. Before I start adding the NaOH, I will add some phenolphthalein. Now, phenolphthalein has a property that in an acidic medium, it is colorless. And in a basic medium, it is pink. In acidic medium, it is colorless. In basic medium, it is pink. So initially, when I have added phenolphthalein over here, because I have sulfuric acid, what is the solution going to be? Colorless. Now you'll notice when you do this experiment in school, let's say you add 1 drop of NaOH. Okay? With the first drop of NaOH, NaOH yahan gira, you will notice that the solution around this drop turns pink. The solution around this drop will turn pink, right? Why is that happening? There is still a lot of acid left, but why is that solution turning pink over there? हाँ? नहीं, phenolphthalein पूरा solution में है, but यहाँ पे जहाँ पे NaOH drop होता है, वहाँ पे एक बार के लिए pink होता है. Yes, the reaction is localized. The NaOH has dropped here, it has not spread out throughout the solution. So what you do, as soon as you shake the flask, the pink color will disappear. It will again become colorless. Then you add more NaOH, you shake the flask, again the color will disappear. You will keep adding NaOH. You will notice that the phenolphthalein, initially you get a pink tinge and then it quickly disappears. So what you have to do, as when you get more used to this, with one hand you control the tap of the burette, and with the other hand you hold the flask. And while adding the NaOH, you should be constantly rotating the flask, so as to ensure that the reaction is not localized. The reaction is taking place throughout the mixture. हर जगह reaction हो रहा है, ऐसे एक ही जगह पे reaction नहीं हो रहा, right? There will come a moment when all the sulfuric acid is consumed. पूरा खत्म हो गया. At that moment, the solution is going to be colorless, because then the pH is going to be 7. The next drop of NaOH will turn the solution pink. Because once all the sulfuric acid is reacted, the next drop of NaOH will make the solution basic, and that will change the color of the phenolphthalein. Phenolphthalein will become pink. At that instant, you have to stop adding NaOH. At that instant, you have to stop adding NaOH, right? ऐसा नहीं कि NaOH डालते गए pink हो गया अब रुक गए. ऐसा नहीं. You have to be very careful, right? It should be colorless. Next drop of NaOH, it becomes pink. At that instant, what will you do? There is a 0 mark over here, 0 milliliters. At that instant, you measure how much NaOH was consumed, right? Let's say 450 milliliters of NaOH was consumed. Then what will you do? You'll simply do that number of moles of NaOH must be 900 because I added, isko bhi kar lo 300, because I added 450 milliliters, because I had 450 millimoles of H2SO4, I must have added by now 900 millimoles of NaOH. So I know the strength of the solution must be 2 molar. Right? You can apply mole concept and get the strength of the solution. So this process of determining the strength of an unknown solution is called titration. And titration is part of your board syllabus. You will have to do this experiment in the school lab. Right? It's very, very interesting. Very, very interesting. ठीक है ना? You have to be very careful. Phenolphthalein भी थोड़ा सा डालना होता है. You have to add very little amount of phenolphthalein because phenolphthalein itself is an acid. So you're adding base, the phenolphthalein also reacts with the NaOH. If you add a lot of phenolphthalein, then your reading will be wrong. Right? You cannot keep adding NaOH. You have to stop the instant the solution turns pink. अगर dark pink हो गया तुम्हारा solution, मतलब गलत हो चुका है. Because one extra drop is going to change the color of the solution and that color will be a light pink. Please remember this. If it is dark pink, you've added extra NaOH and your reading is wrong. It has to be a light pink. Are you getting it? Very important. Any doubts? Titration. I'll be showing you some titrations in class. The more complex ones like double titration, etc. When I teach you equivalent concept, I'll be getting the chemicals here and I'll be showing you that titration. But these things you will have to do in school. Okay? Be careful while using the pipette. When you're controlling the flow of the liquid, ऐसा बहुत बार होगा. You fill in the solution and then it drops below the mark. Then again straw जैसे फिर ऐसे बंद करते हो, फिर धीरे धीरे छोड़ रहे हो, ज़्यादा छूट गया, solution नीचे चला गया, फिर वापस करना पड़ रहा है. So what you can do is you can moisten your thumb. पानी के नीचे thumb को थोड़ा गीला कर लो. उसके बाद when you cover it, you will notice you are able to control the flow of the liquid much better. You'll be able to do that. So use this trick if you're having problems with the pipette. This is called a pipette. P-I-P-E-T-T-E. This is called a burette. B-U-R-E-T-T-E. Burette. Is it okay? Anyway, next. In number question 15 and 16, please make small corrections. In question 15, 6 gram of urea is part of a 900 gram aqueous solution. What is the molality? M-O-L-A-L-I-T-Y. Molality. Question 16 also. 1 molar aqueous urea solution has density this much. Calculate the molality. M-O-L-A-L-I-T-Y. वो दोनों misprint होके molarity हो गया. Please convert both to molarity. And question number 17, part A, वो 5 नहीं होगा, वो percentage होगा. Instead of 5, please make it percentage. Please solve. 60 grams. Molar mass of urea is 60 grams. Urea is this. NH2CO, NH2. This is urea. Molar mass is 60 grams. Please attempt. Question 15, 16 and 17. All right. First question. 6 gram of urea is part of a 900 gram aqueous solution. What is the molality? Now understand, the solution is how much? 900 gram. This is already given. How much of it is urea? 6 gram. What makes up the solution? Urea plus water. This makes up the solution. So how much must be water? 894 gram. Yes. What is the definition of molality? Number of moles by weight of solvent in kg. How many moles of solute do I have? 0.1. I have 6 gram of urea, which is essentially 0.1 moles. So this is 6 by 60.1. And what is the weight of the solvent in kg? 0.894. So the answer is 0.1 upon 0.894. That's it. This is the answer. 0.1 upon 0.894. Straightforward? Okay. Next. Question 16. How will you begin question 16? Have you solved? How will you begin question 16? Now, Remember I told you that strength is like temperature. It does not depend on amount, right? If I have a 1 liter solution in which I have 1 mole of, let's say, H2SO4, sulfuric acid. What is the molarity of the solution? 1 by 1. So it is 1 molar, right? So this solution has, let's say, a label on it which says 1 molar. If I take out part of this solution, what will be the strength of this part? 1 molar. The strength will remain same. Think about it. Say I take out half of this solution. मैं आधा बाहर निकाल लूं. So what is the volume of this? 0.5 liter. How many moles of solute are present over here? 0.5 moles. Right? Because originally I had 1 mole of sulfuric acid. Now I'll have half mole of sulfuric acid. So what is the molarity? 0.5 by 0.5. It is still 1. It is still 1. So no matter how much of solution I take out, its strength will remain same. So in this problem also, problem 16, I can begin with how much ever of solution I want. The strength is going to be same. It does not depend on the amount. It's an intensive property. So take 1 liter of solution. Take 1 liter of solution. Now, because the strength is given as 1 molar, how many moles of urea are present in it? 1 mole. If I have 1 molar strength and 1 liter solution, then the number of moles of urea inside it is 1. So this contains 1 mole of urea. Yes. What is the weight of the solution? How will you get this? The density is 1.2 gram per ml. This is the density of the solution. So what will be the weight of this solution? 1 ml weighs 1.2 gram. So if I have taken 1 liter of solution, this is how much? This is 1000 ml. 1000 ml will weigh how much? 1200 grams. So I have a 1 liter solution in which I have 1 mole of urea and the solution weighs 1200 grams. Now it's very easy. Urea plus water is the solution. In 1 liter, I have 1200 grams of the solution, out of which 1 mole is urea. How much weight is that? 60 grams. So the remaining 1140 grams must be water. The remaining 1140 grams must be water. Yes or no? Makes sense now, right? Now do the calculation. First, small m, molality will be what? Number of moles by weight of solvent. Number of moles is what? 1 mole. How much is the weight of solvent in kg? 1.14. Finished. In molality, the denominator has weight of solvent, not weight of solution. Very important. The answer is 1 by 1.14. Right? Next. What will be percent weight by weight? It will be weight of solute, which is 60, upon the weight of solution, which is how much? 1200. So 60 by 1200 into 100, this comes to 5%. So this solution, which I am calling 1 molar urea, I can also call it 5% weight by weight of urea. It's the same solution. I'm just expressing the concentration in different ways, right? I can also express it as percent weight by volume. I will have to use the weight of solute in grams and the volume of solution in milliliters. How much is the weight of solute in grams? 60 gram. How much is the volume of solution in milliliters? 1000 milliliters into 100. So how much is this? 6%. वही solution अगर weight by volume में बता रहे हैं तो उसका concentration is 6%. If I'm expressing it in weight by weight, it is 5%. If I'm expressing it in molarity, it's 1 molar. If I'm expressing it in molality, it is 0.9 something, right? I can also calculate the mole fraction of urea. How much will this be? Number of moles of urea, which is 1, divided by total number of moles, which means number of moles of urea plus number of moles of water. How many moles of water do I have? How many moles of water do I have? 1140 by 18. The water is 1140, right? Okay, solve. Are you getting it? Right? Okay. All right. Your homework for next class is section E, POAC we've covered today, and section F, concentration terms we've covered today. You can also now finish home assignment 2, 28 questions.